Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest, maximum number of non-overlapping palindrome substrings. The problem states that you are given a string s and a positive integer k. You have to divide this string s, or maybe select a set of non-overlapping substring from string s. Okay, and what those non-overlapping substrings should satisfy, that each of those substring length should be at least k, and each of these substrings should be a palindrome. Okay, so two things you have to like select some substrings from s which are non-overlapping. The length should be at least k and each substring should be palindrome. Okay, you have to select such that you can select the maximum number of substrings, and that's what you have to return. Okay, so uh, let's take this example. So a b a double c d b b d. Okay, so in this what they are saying is we can select these two substrings. These two substrings are valid. Why? First of all, they are both palindrome. ABA is palindrome, D double B D is palindrome. Then each of these have length which is greater than equals to 3. So this is of length 3, this is of length 4. So that is also satisfied. So these both condition is satisfied. And then they are non-overlapping as well, right? So that's where this is a valid arrangement, and we get to select two substrings. And you can try any other possible combination. You would not be able to select more than two substring which satisfies all these conditions. Hence the answer is 2. Okay, now let's see how to solve this. Again, we will not directly jump to the solution. Instead, we will try to build it incrementally. Okay, so think about it. What what exactly you have to solve? You are given that you have to select some substrings which are not overlapping. Okay, focus on not overlapping. Because they are not overlapping, let's say you select some substring. Just assume that you select some substring. Can you just say that now the rest of the problem is now independent of whatever you have done? Answer is yes. So basically what you are saying, if you have selected some substring, you can simply say uh, what is the maximum number of substring that I can select from the remaining string. So basically exact same problem but with reduced constraint. Okay, so this is a clear recursion case, right? So when you are trying to find out the answer for the entire string, you can take some substring and then try to find out the same value, the exact same question result for the remaining string. Okay, now the problem is how can we select this substring? Okay, so basically we know that if we select some substring, we can divide it, and we can solve for this part independently, like basically calling the same recursive function. Okay, but now how to select this in the first place? So now there are two conditions. If you remember, the substring should be palindrome and substring should be at least k. So non-overlapping we considered already, like because they are non-overlapping, that's where we are able to come up with this recursive intuition that if we have selected something, the next should be independent of the current selected substring. So we can solve the problem independently for the next set of next remaining string. So that's where non-overlapping is already taken care of. We have now two more condition. Each substring should be palindrome and length should be greater than equals to k. Now, first is like length should be like, which of these two are easy to easy to opt for? The first one, right? Because length should be at least greater than equals to k. So what you can do, let's say you are starting at this position and assume that k is 3. Okay, so this is k. Now what you can do, you can try to find out what we are trying to find out. We are trying to find out what substring we can remove, right, from the first position. So we can remove only the substring which are greater than length k, right? So one possible candidate is to remove this substring. Next possible candidate is to remove this substring, and then next candidate is this. This is also a candidate. This is again a candidate, and this is again a candidate, and finally this is again a candidate. So these are the possible candidates which can come in the first string. Okay, so what you are doing, what we are saying that we will take each of those candidate one by one, because we have to find all possible all possible solutions. Like among all possible solutions, we need to find out the optimal one, right? So we will take all possible choices or all possible options. What are the possible options? Options are, you select this candidate and then you solve for the remaining string. The next option is you select this candidate and then you solve for the remaining string, and so on and so forth. But there is one more condition. We have only taken care of length condition. We haven't taken care of palindrome. So now, whenever we are taking a candidate, we can just see if it is a palindrome or not. If it is a palindrome, then it is a valid candidate, and we will move forward with the next. Move forward to solve the question or to solve the problem for the remaining substring. If it is not a palindrome, let's say you selected this candidate. Now this candidate is not a palindrome. So if it is not a palindrome, your this candidate itself is not valid. So why would you move forward? Okay, so you will select all valid candidates. Okay, so just to reiterate how we have reached here, we said that each substring should be non-overlapping. So that's where we find out that we can apply recursion here. Recursion is very intuitive here. Next, we found out that we need to apply recursion, we need to first lock the first substring, and then only we can apply the recursion or solve the problem for the remaining substring, right? So to find out the first substring itself, we have to satisfy, or to find a candidate, I mean that candidate need to satisfy both of this condition. Length should be at least k, and each substring should be palindrome. So we started out with length should be at least k. So what we have done is each substring, we tried all, we said that we will try all possible candidate of length at least 3, and then we have said that of all those candidates, we will select those candidates which satisfy the second condition as well, which is each substring should be a palindrome. And if a candidate satisfies that, then it is a valid candidate, and we'll move forward to solve the problem for the remaining string. Okay. So now write. Let's try to write recursion, the formal recursion. So let's say you are given a index. This index denotes starting from I, or this function denotes starting from I, what is the maximum number of substring that I can make, which satisfies these conditions. Okay, so this is what f of I denotes. Now, as we discussed, from I, we can let's say this is I itself. Okay, so from I, we have lot of candidates. We can first select this candidate or this candidate or this one, right? So what we will do, we will apply a for loop here that will go over all these candidates, right? Now, for each of those candidates, we'll check whether it is palindrome or not. Okay, so whether it is palindrome or not. So let's say there is a function already which says whether the string is palindrome or not. It takes 2 point starting index and end index, and it will just give you true or false. So you will call this function that starting from index I, okay, and ending at this particular index, right? Ending at this particular index, whether it is palindrome or not. If it is a palindrome, then this is a valid candidate, and because this is a valid candidate, what is the answer? We will take answer as maximum of whatever answer that we got from the previous candidates plus a comma 1 plus the value, or the value for the next remaining strings. Okay, so this is one possible candidate answer. Similarly, we will try every possible candidates, find out the answer for each of those candidates, and take the max. Now, there is one more thing here. We have considered all the candidates starting from here, right? But it is not necessary, right? there can be cases where this candidate is not there. Like this candidate itself, like A will not form any candidate. There can be cases. There can be cases that only B will form, like only B will form some string, right? So that's where what you will, like after doing all of this, you have one more cases. One more case is to, you don't consider I at all. Like you don't consider any candidate that started with I at all. You considered some candidates, right? Now the next thing is, you don't consider any candidate that start with I. Just call f of I plus 1. That is again a valid option, right? So just to summarize, this is how our pseudocode would look like. We need to find out max number of palindromes starting at given index I and D. Now, if index is the ending index, we can't find anything, we just return 0. Otherwise, we are iterating over all possible next indexes. Okay, and what are the possible next index, next end indexes? Basically, each of these candidates that we are considering should be at least length k. So the candidates will start from this particular index and will go up to this. Now, each of what this end index means, basically, this is the starting index I, and this is the ending index that denoted by this variable. Now, we will try every possible candidates starting from this up till this, and like all the way up till this candidate, right? And for each of these, we are checking whether it is palindrome or not, or basically whether it is a valid candidate itself or not. If it is a valid candidate, then we can say, okay, this is a valid candidate. Now we know that we got one substring that is valid. Now just solve the question for the remaining string. So that's what we have done. We taken the result equals to max of result comma. We know that we got one substring, and we take the maximum. We call the same function with the next index. Okay. Now after doing all of this, there is one more choice. The choice is to not start any candidates at A itself or at I itself. So that's what we have done. We said that okay, there may be cases where there is no candidate that starts with I. So just take max of result comma max palindrome of index plus 1. Okay. So that's pretty much. Now what is the time complexity of this entire solution? We how much we can memorize it so that we only solve for a particular index exactly once. So how many times, or like how many unique indexes with which this function can be called? N, right? The total n length of the string is n, so only n possible unique indexes are there. Now for each indexes, what we are doing is we are iterating over end indexings. So in worst case, k can be 1, so you will iterate over all the remaining string. So this is again n, right? And inside each of these indexes, we are calling is palindrome. So basically, whatever the complexity of is palindrome is, that will come here, and that is the total overall complexity for this function. Okay. Now, and also this complexity is after memoization, because otherwise this n that you take in would not be true. Like you are saying that only n possible n unique times we will be iterating over this logic. Otherwise we will save the result for the previous iterations and return it if asked for. So now think about it. What is n? N is up to 2000, right? So n square itself is very huge now. So what exactly you can opt for here? So one possible way of implementing is palindrome is just simply iterating over the string from start and end. That will give us order and complexity. But order and complexity we don't want. Otherwise it will become order n cube, which will not pass. So what is the maximum that we can afford here? Either log n or order 1. That's it, right? So now we have to solve this particular problem, that given a start index and an end index, tell me whether it is palindrome or not in order 1 time or order log n time. If we are able to do that, then this solution makes sense. Otherwise, if you remember, we have started with non, or like we have started with the hint that the substrings would be non-overlapping, and that's where we choose this recursion path. And if we are not able to solve this particular problem in order 1 or order log n time, we have to opt out for some different path. I'm just trying to share my thought process during the contest. So now we have to solve for whether a string is palindrome or not in order 1 or order log n time. We can't afford order n time. So Now you are given a start and the end index. Let's say this is your start index and this is your end index. Okay. Now what you can do, you can simply say, okay, why not apply recursion here as well? It's like one option is to just do iteration, like you just move this pointer to the left, to the right, and this pointer to the left, and just compare. This is one option that will require order in time, but you have to do better, right? So what you can do is you can just think of applying recursion here as well. So this is also a recursive problem. You can see if they are equal, then you need to find out whether this substring is palindrome or not, right? And if they are not equal, you can straightforward return false because they can't be palindrome at all. Like if the character at the start and character at the end are not equal, you can simply say this is not a palindrome. And if they are equal, you can simply call is palindrome of start plus 1 and minus 1. That's it, right? So this this is something that you will do for each start and end. You will check whether, like, this is the base condition, like if start is equals to end or start is greater than end, you will return, sorry, this will be true, right? So it will be a palindrome because the string is either of length 1 or length 0, so this is a palindrome. Otherwise you will check whether they are equal or not, the value at start and end is equal or not. If they are not equal, just return false. If they are equal, then just return the is palindrome of st plus 1 and ed minus 1. Okay. Now, what is the time complexity of this is palindrome function? You can think this complexity is order 1. Like you are doing the operation order 1 time, but you are calling is palindrome as well, right? Now, how many unique time this is palindrome, or how many unique values is this palindrome will be called? What is the number of unique pairs of st comma ed? Total n square pairs can be there, right? Now, because total n square pairs can be there, and in each pair you are doing order 1 operation, right? You are doing order 1 operations. So you can simply memorize this function as well. You can simply memorize this function as well, and you will be able to tell whether, like, overall in order n square, you will be able to tell whether a string is palindrome or not, right? In total n square, you can tell for every possible start and end. Okay, so in essence, this is not exactly order 1. What we are saying is across all across all the functions, or across all the calls of is palindrome start and end, if we sum this up, this will be order n square. So what is the total time complexity? Total time complexity would be order n square plus order n square, right? That's what the time complexity is, and that will surely pass. Okay, so just to reiterate, we started with non-overlapping. We found out that we can apply recursion here. We then saw there are two conditions to select a candidate. One is to it should be of length greater than or equals to k, and second is that it should be a palindrome. So we started with the first condition because that was easy. We found out all candidates, and from all those candidates, we again filter out by saying that whether it is palindrome or not. Now, if the candidate is valid, that it satisfies both the conditions, then you found a valid candidate. You do 1 plus and solve the question for the remaining string. Now, one more choice was there, that you can't start with it may happen that you will not want to start with the current index at all. In that case, you just do max palindrome of index plus 1. Now we found out that the complexity itself was order n square already, and we can't afford anything else. So we try to uh, optimize this is palindrome function itself. So what we have done is what we have said is we can apply by recursion here as well. And after applying recursion, we saw that overall in order n square time we can answer this function for all possible start and end indexes. Okay, so what we have said is this is not exactly order 1, but across all such st and ed this will be order n square. So that's what the time complexity is. Now the solution, the code is very or exactly similar to what we discussed. We have these two memoized values. Why I take bool I will explain, but just bear me for a moment. So we just return max palindromes of 0ks. Okay, and what is this? This is exactly what we discussed. if index is n, we return 0. Otherwise, we'll check whether we have already calculated this index or not. If we have calculated, like initially we put everything is -1. So if it is not -1, it means we have calculated this. And if we have calculated this, we just return that particular value. Otherwise, we know the one possible choice is to just take just skip the this particular index and try for next index. So that is what we have initialized our answer with. And then we iterate over all possible candidates and determine whether that candidate is valid or not. If it is a valid candidate, we know that we found one valid substring and we have to solve the problem for the remaining substring, right? And that will give us one possible option. So that's what about max palindrome was. Now, east palindrome is again very similar, which we discussed. If they are equal, we will just return st plus 1 ed minus 1. If they are not equal, we will just return false. Okay. And there is one more thing. If we have calculated the value for this particular st and ed before, we just return that particular value. Now, coming to this boolean. So initially we have initialized this particular max palindrome. Like we have also memoized this max palindromes, right? And we have initialized everything to -1. But with boolean, we have two choices, true or false, right? So you actually can't have third value which can denote that whether this particular pair is computed previously or not. Okay. So for that, I have taken one more uh, boolean is calculated, right? Sorry. So we have taken one more boolean is calculated, and we are checking this value whether it is calculated or not. Initially, everything is false. Nothing is calculated initially, and if it is calculated, we'll return the value of each palindrome. Okay. So hope you understand why I took booleans here. Okay. So if you have any doubts in this problem, please post them in the comment section below. I would be happy to answer. And also one more thing before we go, notice that we are calling this function with a string s. Now, this function would not work if you pass different string here. You have to pass exactly same string here. Why? Because whatever you have computed previously is based on this string. Okay, so don't think about it that this string can be changed. So to simplify, what you can do, like to just if you are a beginner and you are not able to do you take make your mind that this is a valid choice, just remove s from here. Okay, just remove s from here and just make s here. So let's just keep it rename the variables so that they don't collide. Just keep this thing. So if you do this, you will not be misguided by the fact that you can send any string here. You have to send the exact same string, otherwise whatever calculation you have done is not, it can't be reused. Okay, so that is one important point. Okay, so hope you like the solution. If you like the video, give it a thumbs up. Do subscribe to the channel if you haven't already, and I will see you in the next one. Thank you.